For most missions, our customers provide artwork, which is added to the payload fairing. For today's mission, there are 10 stars organized around the perimeter to reflect the 10 WGS missions. The Hang 10 and Shaka hand symbol pay homage to Boeing's Southern California Satellite Production Center and the local pastime of hanging 10 toes off the front of a surfboard. At the bottom we read, "For the Warfighter," to remind us of the impact and purpose of the WGS constellations. Finally, the platypus with a ray brings us full circle as it re-emerges from the very first WGS logo. This is Delta Mission Control. We are about to enter a planned 10-minute hold.
T-minus 4 minutes in holding. This is a 10-minute built-in hold.
ALC, please adjust the clock for a new T0 of 23:11:000.
Roger.
LC switch to the not ready position.
Built in Decatur, Alabama, the Delta IV Medium Plus 5.4 includes a common booster core powered by an Aerojet Rocketdyne RS-68A engine and 4 orbital ATK solid rocket motors. An Aerojet Rocketdyne RL-10 B2 engine powers the Delta cryogenic second stage. WGS-10 is protected during ascent by a 5-meter diameter payload fairing. Final launch preparations began on February 18th when WGS-10 was encapsulated inside the payload fairing. On February 26th, the encapsulated payload fairing was transported to the Mobile Service Tower, or MST, at Space Launch Complex 37 and mated to the Delta IV rocket. Approximately 9.5 hours ago, final preparations began at Space Launch Complex 37. Using 40 hydraulic cylinders at pressures nearing 3,500 psi, the 10 million pound MST was raised 8 inches and rolled back, revealing the Delta IV launch vehicle. Using a carriage transporter system, traveling at about a quarter mile per hour, it takes about 25 minutes to roll the MST to its final position 345 feet north of the Delta IV rocket. The Delta IV rocket stands 217 feet tall, or about 21 stories, and weighs more than 900,000 pounds fully fueled. The RS-68A main engine and 4 solid rocket motors combine to produce approximately 1.7 million pounds of thrust at liftoff. About 4 minutes later, at stage separation, it weighs just 10% of what it did at liftoff. This is Delta Mission Control at T-minus 4 minutes in holding. Today's launch will deliver the 10th satellite for the Wideband Global SATCOM system. Built by Boeing, WGS is an important element of a new high-capacity satellite communication system, providing enhanced communications capabilities to U.S. and allied warfighters for the next decade and beyond. Each WGS satellite provides more wideband communications capacity than the entire defense satellite communications system the constellation WGS is augmenting. Later in the broadcast, we'll learn more about the WGS mission when I'm joined by Tim Maurer, Boeing software engineer, and Sam Wiley, U.S. Air Force Twitter account, and the first person to comment on the question with the correct answer will receive a very special prize. Answers and winners will be announced shortly before spacecraft separation. In addition to watching our webcast, you can always follow live mission progress at ulalaunch.com.
LC1 is AC.
Go AC.
Okay, we're still working, troubleshooting on the CVC bottle press and the high flow demand. We do not have a workable plan yet, and we need to continue our troubleshooting. I do not have an estimate for you at this point.
Roger that. And for the team, I'll continue down just prior to the L7 pole, and we'll stand by at that point. LD, LC, net 1.
LD-L1.
And with that expectation, as stated, I'll proceed down towards the L7 pole, hold off there, and at that point, I'll give you direction. We'll extend the hold.
Concur.
All communications switch to channel 1. All personnel and visitors remain in present position until launch. Maintain operational silence in the LCC.
RC, verify solar radiation limits acceptable for launch.
Verified.
Terminal count briefing. If a condition exceeds a launch constraint any time after a terminal count status check, the observer shall announce hold, hold, hold on channel 1, identify their station, and briefly state the reason for the hold. Flight control, LC.
Flight control.
Perform launch on time verification. OSM, verify the whole fire switch is in the proceed position.
Whole fire switch is in the proceed position.
RLM, verify red line monitor and vent table are in the correct configuration for terminal count.
Verified.
As you just heard, the team is currently working an issue. We plan on extending the built-in hold to work this issue. This evening's flight is dedicated in memory of Kurt Hushley, a colleague, friend, and patriot. During his 30-year aerospace career, Kurt held critical roles on multiple programs, including High Indo-Atmospheric Defense Interceptor, Nighthawk, Space Station, and various classified programs. He finished his career as electrical installations lead for Delta IV. Kurt was a supportive coworker, sharing his wealth of design knowledge, as well as a consummate professional, always able to deliver a quality product while adapting to design changes and keeping pace with a rapid launch rate. Kurt was a caring individual, dedicated to his career, family, and friends. He exuded joy and humor wherever he went and will be remembered and missed by all he touched.
SYS.
NLC, this is flight control on 1.
Go.
Launch on time, verified.
Roger. Okay, all personnel, all steps are complete prior to status check except for the troubleshooting we're working on with the pneumatic system. All personnel will stand by, and LD, LC, at 1.
LD on 1.
Yeah, at this time we're in need to extend the hold at T-minus 4 minutes.
Roger, concur.
This is Delta Mission Control at T-minus 4 minutes and holding. We remain in the planned 10-minute built-in hold as preparations for launch continue. Soon, launch conductor Scott Barney will pull the launch team for the final go to pick up the countdown. 27 engineers and managers are pulled for system status and readiness to proceed. This is the final status check before launch for all Delta vehicle systems, ground systems, the spacecraft, and the U.S. Air Force Eastern Range. The vehicle system readiness pool includes electrical systems, hydraulics, pneumatics, propulsion systems, flight control, and propellants. If you are just joining us, the team is currently working an issue as we remain in the planned hold. We will continue to update you as information becomes available. Not only do we have the broadcast you are currently listening to, we also just started a blog which can be viewed at our website, ulalaunch.com. Also, to stay up to date with the most recent launch information, please visit our social media, which is at ULA Launch, at Twitter, and on Instagram.
LC, this red line monitor.
Go red line monitor.
Roger, we picked up an OTC on the second stage, LOX airborne tank, PU delta pressure. It's just above the upper limit of 4.76.
Roger. ACLC net 1.
ACL 1.
Yes, RLM is reporting an alarm, second stage LOX airborne tank, PU delta P press. Please convene anomaly team provide recommendation.
Wilco.
This is Delta Mission Control at T-minus 4 minutes and holding. The team is currently working the issue reported earlier through a test. While we wait, let's look at some launch footage from the previous 9 WGS launches, all atop United Launch Alliance, Atlas V, and Delta IV rockets.
WGS-10 spacecraft telemetry data has been acquired. Congratulations.
Liftoff of the United Launch Alliance Delta IV rocket carrying the WGS-3 spacecraft of the United States Air Force.
And we have liftoff.
Liftoff of the United Launch Alliance Delta IV rocket carrying the WGS mission for the United States Air Force.
This is Delta Mission Control at T-minus 4 minutes and holding. 2 tests have been run to resolve the issue reported earlier, and both have been successful. We are still awaiting an update on a new T0.
LCN1, this is AC.
Gracie.
Okay, radio out brief, both of the anomalies we've been working.
Roger, LD net 1.
LD1.
MD net 1.
MDM1.
Proceed, AC.
Okay, first one was the second stage LOX Delta P that had the RLM trip. We have reviewed that. It was based on the situation at the time. No impact to proceeding with count. Our recommendation is proceed.
LC concurs, LD.
LD concurs.
MD.
MD concurs. Okay, second was the ongoing attempts to establish the booster bottle press scenario. We have established and shown repeatability with our latest plan. The P&E operator has shown that the recovery works fine with the set points we've established. We're recommending disabling 2 lines in RLM. That'd be line item 1 and 9. And we've established with the P&E operator also the limits to be monitored to and at what point it would need to call hold if it does not make it. We do have confidence in this plan and recommend proceeding.
LC concurs, LD.
LD concurs.
MD.
MD concurs.
PNE, LC net 1.
P&E's on 1.
Roger. First, Q verify CBCs at flight bottles are at flight pressure.
CBC bottles are at flight pressure.
Roger. And you are ready to proceed with the anomaly team recommendation.
Yes, I've been listening into the anomaly team recommendation and ready to proceed with that.
Roger. RLM, LC.
Go ahead.
Please disable line items 1 and 9 for anomaly team direct.
Roger, inward. Line items 1 and 9 have been disabled and verified in the Redline Monitor program.
Roger.
This is Delta Mission Control at T-minus 4 minutes and holding. The launch team has worked two issues and is ready to proceed with the launch count. We are still waiting on the official announcement of a new T0.
LCM1, this is AC.
Go AC.
Okay, we need to readdress the Delta P second stage launch recommendation. Some additional information has been reviewed, and I need to go to 6 with this.
Roger. Proceed to net 6. Provide a recommendation.
We'll go.
LCS Redline Monitor.
Go Redline Monitor.
Roger, we did trip the same OTC on the Delta P that we had discussed earlier, and the anomaly team's discussing it on 6.
Copy that.
LC on 1 is AC. Ready to outbrief the second stage Delta P issue.
Roger, LD net 1.
LD on 1.
MD net 1.
MD on 1.
Proceed, AC.
Okay, team evaluated a little further, recognized we were close to the top of the limit. We have recommended a new topping target and also the disabling of line item 272 on RLM. And with that, we recommend proceeding.
Roger, and that new topping target is set now, correct?
That is correct.
Roger. LC concurs. LD.
LD concurs.
MD.
MD concurs.
RLM, LC.
Go ahead.
Please disable line item 272.
Roger, in work. Line item 272 is disabled and verified in the program.
Roger.
LC, LD on 1.
Go LD.
Yes, sir. Please coordinate a new T0 of 23:52.
Roger, 23-52000.
Good copy.
RC, LC net 1.
RC on 1.
Please coordinate a new T0 of 23-52000.
That was 2352 Zulu.
Correct.
Copy and work.
ALC, set the clock for 23-52 Zulu.
Roger.
LC, ALC.
Go ALC.
Countdown clock has been set for a new T0 of 23:52. We're currently at L-14 minutes.
Roger.
L-14 minutes.
This is Delta Mission Control at T-minus 4 minutes and holding. As you just heard, the team has established a new T0 of 7:52 p.m. Eastern Time.
LC, RC net 1.
Go RC.
The new T0 of 23:52 has been coordinated and approved by the range.
Roger. Okay, all personnel, our clocks are set. We have an approved T0, just under L-13 minutes. We'll pick up the status check at L-7 minutes.
LC, RC on net 1.
Go RC.
TDRS is red at this time, unable to support mandatory telemetry collection. We are no-go for TDRS.
Roger.
Expected resolution is beyond our currently planned T0.
Copy.
This is Delta Mission Control at T-minus 4 minutes and holding. An issue with NASA's Tracking and Data Relay Satellite System, which provides mandatory collection of Delta 4 ascent data.
LD, LC, net 1.
LD on 1.
Yeah, with the issue reported by RC with the TDRS 41 issue, I recommend extending a hold at this time.
LD concurs.
All right, team, monitor all your systems. Keep launch vehicle readiness prepared. We'll allow the range team to work the issue and look for a successful resolution of that and pick a T0 within our window.
This is Delta Mission Control at T-minus 4 minutes and holding. The range is working a tracking satellite issue that is a requirement for launch. The Delta IV is currently ready to launch and awaits a resolution and new T0. The window tonight extends to 9:05 Eastern Time. The venerable Delta family of rockets have been launching into space for decades. Let's take a look at the amazing history of the Delta rocket.
On January 20th, 2011, a Delta IV heavy launch vehicle lifted off from Space Launch Complex 6 at Vandenberg Air Force Base, carrying the L-49 mission for the National Reconnaissance Office. More than 50 years in the making, the Delta IV Heavy was the largest rocket to launch from California's western range and was a fitting tribute to Delta's legacy of support to our nation.
We have liftoff. Liftoff of the United Launch Alliance Delta IV Heavy rocket carrying the NROL-49 mission for the National Reconnaissance Office. This marks the first West Coast Delta IV Heavy launch.
Though first launched in 1960, Delta's story really begins in the mid-1950s with the development of the Thor Intermediate Range Ballistic Missile. Named after the Norse god of thunder, Thor was created in response to a growing fear that the Soviet Union would beat the U.S. in the deployment of a long-range ballistic missile. The goal was to design a system that could deliver a nuclear warhead to a target 2,300 miles away, the distance between the United Kingdom and Moscow. On January 25, 1957, the first Thor lifted off from the newly constructed Space Launch Complex 17 at Cape Canaveral. Following a series of early failures, the Thor team celebrated their first success on September 20, 1957. In all, 59 Thor IRBMs were launched, with the last flight occurring in 1975. Thor began the transition from missile to space launch vehicle in 1958. On October 11, 1958, America's newly formed space agency marked its inaugural launch when Thor Able boosted NASA's Pioneer 1 on a mission to the moon, and NASA's long partnership with Thor was born. NASA and the Douglas Aircraft Company began development of the fourth and longest-lasting Thor configuration in April 1959. Using a Thor first stage and a Vanguard second and third stage, Delta I lifted off on May 13, 1960, from Cape Canaveral's Space Launch Complex 17. Though its first launch was not successful, the Delta team quickly pinpointed the failure and 3 months later delivered NASA's Echo 1 communication satellite to orbit. Following Echo 1, the Delta team racked up an impressive 22 successful launches. Led by Bill Schindler, the Delta rocket earned its industry workhorse moniker for rapidly establishing itself as one of the most reliable and versatile launchers. During the 1960s, Delta launch vehicles paved the way for the burgeoning communications industry, launched America's first weather satellites, and sent probes to explore our universe. AT&T's Telstar-1, first commercial communication satellite, launched in 1962. And in 1963, SYNCOM-2 became the world's first geosynchronous satellite. TIROS, or Television Infrared Observation Satellites, provided the National Weather Service with man's first view of the Earth's cloud cover. In orbit around the Earth, Moon, and Sun, NASA's Explorer satellites provided us with a deeper understanding of the solar wind, cosmic rays, and Earth's magnetic field and radiation belts. By the end of the decade, launch vehicle modifications, including the addition of solid rocket motors and an upgraded third stage, made it possible for Delta to orbit satellites 10 times larger. The 1970s was an international decade for Delta, as the manifest included scientific and communication satellites for several countries across North America, Europe, and Asia. Perhaps the most demanding challenge of the 1970s was the launch of the Earth Imaging Earth Resources Technology Satellite. Later known as Landsat, the mission for the Earth Sciences community required major changes to the Delta propulsion and guidance systems. During the 1980s, Delta continued its reliable service to the communications, weather, and Earth imaging communities. But as capable as the Delta rocket proved to be, production came to a halt in the early 80s when national space policy dictated that the space shuttle be used as the U.S.'s primary launcher, signaling the end of the expendable launch vehicle. But in 1987, the Delta team picked up where they left off, and development began on a launch vehicle to support the Air Force's Global Positioning System. On February 14, 1989, Delta 184 began a new chapter in space launch history as it lifted off from Space Launch Complex 17. Demonstrating an incredible feat, the Delta II had gone from development to launch in just 2 years. To accommodate the larger GPS satellites, engineers improved the Delta rocket in several ways. The fuel tanks were stretched, a new payload fairing was developed, and larger solid rocket motors were incorporated. The modifications resulted in increased performance and flexibility. By the mid-1990s, the Delta II had delivered the fully operational 24-satellite GPS constellation. And though it was developed for the Air Force, Delta again became a reliable partner to both NASA and its commercial customers.
We have good separation on all 3 airlit solids.
Over the course of its more than 20-year run, the Delta II has launched some of America's best-known scientific and exploration missions.
We have main engine start, 0, and liftoff of the Stardust spacecraft, and liftoff of the Delta II rocket carrying the Spirit from Earth to planet Mars.
Liftoff of the Delta II with Grail.
On the commercial side, Delta II launched the Globalstar and Iridium constellations, which brought satellite telephone communication to the world. Continuing its evolution to meet the growing demands of its satellite customers, the Delta team developed the more powerful Delta III. Though short-lived, the Delta III doubled the performance of the Delta II.
So we have ignition and liftoff of the Boeing Delta III rocket.
In partnership with the Air Force's Evolved Expendable Launch Vehicle program, the Delta team began development of the next generation Delta IV rocket in the mid-1990s.
Main engine start.
And we have liftoff of the first Boeing Delta IV rocket carrying the W5 telecommunications satellite for Eutelsat of France.
All Delta IV configurations begin with a common booster core, powered by the RS-68 main engine. Solid rocket motors provide additional thrust at liftoff, and the choice of a 4 or 5 meter diameter payload fairing allows the Delta IV to more precisely accommodate varying payload sizes. The Delta IV Heavy, with its 3 common booster cores, delivers our nation's largest missions to orbit.
Liftoff of the United Launch Alliance Delta IV Heavy rocket carrying the NROL-32 mission for the National Reconnaissance Office.
Delta IV launch vehicles are produced at a 1.5 million square foot state-of-the-art facility in Decatur, Alabama. Processing and launch takes place at Space Launch Complex 37 at Cape Canaveral Air Force Station and Space Launch Complex 6 at Vandenberg Air Force Base in California.
Range safety arm light on.
From its early beginnings as a weapon and deterrent through its transformation into a space launch vehicle, Delta has reliably supported our nation for more than 50 years. Delta's legacy as a workhorse continues today and is a testament to the persistence, dedication, and commitment of an enterprising team that has continually evolved the Delta rocket to support a changing world.
And liftoff of the United Launch Alliance Delta IV rocket.